Alright boys, we are about to start with the presentation of the telescope which is right in front of you. This telescope is a medium category telescope. There are basically three category telescopes. One is the beginner telescope, the other one is the medium category telescope, and then on the higher end of the telescopes, we have got a lot of different subcategories. So, although this looks like quite a normal one, but because of the focal length of the mirror, of the inclination, there are a few things which make it stand apart from the other telescopes. First, I thought of bringing my own telescope over here in the class in order to show to you what is the difference between a primary telescope and this telescope. Some of you must have seen my videos, you must have seen that a primary tube model telescope is the one in which the eyepiece is 90 and we normally look at the telescope through the lens like this, and we do not have any focuser. Over here we have got different things which are not there in the primary telescope. I am going to show to you what are the different aspects of this telescope. If you can help unwrap this. Basically, it has got the main tube over here, and then we have got different lens to view the celestial sky, view the moon, view the stars and the planet. The planets that we can see, is there a phone marker? Do we have one? The planets that we can see in the night sky basically are Venus, Jupiter, Mars, Saturn. These are the planets we can see with the help of this telescope. Now, because of the advanced feature of this telescope, this has got basically two parts. The mirror is at the back of it. This is the main mirror inside it. So, this is basically inside it. I am going to take off the cover. As I have taken off the cover, I am going to rotate it so that you can see a mirror inside. As you can see the mirror inside, this is the basic mirror which collects all the light, all the visible light in the night sky. It collects the light and then it reflects back on a single point, and the point is over here. So there is a secondary mirror that projects the image, where if you can look at the finger, there is a small mirror over here and it projects the light to where your eyepiece is going to be. So we take out this cover, and as you can see it can move to and fro. Now there are different lenses that we can use. This is the primary lens. With the help of this primary lens, we can look at the objects far off. This is for viewing the planets with a lot of clarity. We take off this cover. Now this is ready to be used, right? So what this is going to do is that this is going to magnify the image that is already there. So I put this over here. The way we use it is, we unscrew it so that there is a space over here. It can slide inside this tube. Once it gets slided inside the tube, I am going to fasten this nut like this, and then it's ready to be viewed. So what I can do is, because this is not a night sky right now, so whatever I see is going to be light and nothing else, right? But this is how we use it in the night sky. Then we look at it from this side, and then before we do it, it is very difficult to target a star in the night sky. It's like a needle. It's just like a needle. Any star, any planet is going to look like a needle. So this is basically the targeting pod. Or we call it the focuser, or there is a cross inside. Just like in a gun, in a sniper rifle, there is a cross inside. What you have to do is first you have to look through this targeting pod. Any planet and star you want to look at, first you are going to get that planet inside this cross. There is a cross inside. You have to get the planet inside the cross, right in the middle of the cross. Once you get that planet right in the middle of the cross, it is ready. So what you can do is now you can lock so that it doesn't move, because it takes a lot of time to focus, right? So once it gets focused, you do not want it to move. So what you are going to do is, for example, I have got the Jupiter locked in over here. Now I do not want this to move now, right? Up or down. So what I am going to do is that if it is locked, I am going to tighten this screw, which I am not going to do right now because I am not going to put a lot of strength in tightening the screw. Once it is locked, now it is a bit hard to move, right? It's a bit locked. This already is a bit hard to move. So what I am going to do is I am not going to touch this tube now. I am not going to touch it. So the only thing that is left to do is I am going to slide it up or down in order to focus on Jupiter, on Mars, on Saturn, or on Venus. So I am going to focus it. Once the image is clear, I am going to leave it over here. Now, then other people can come and they can view it from this lens. I can change the lens, however. This is a 25 mm lens, basically for viewing the moon and the planets both. So it is only, the difference is only going to be that of clarity of looking at the planets. Now the question comes, what we can look with through this telescope? We can look at, of course, Venus. When we look at Venus, we find out that there is nothing to look at Venus but a white circle, because this is all atmosphere, this is all carbon monoxide over there, methane gas. Once we look at Mars, it is a red planet, so we will see it as a red planet ball. If we look at Jupiter, yes, I'm pretty much sure that we can look at the Jupiter with the rings over its surface, not around its surface, over its surface. So, and there is a red, what we call it, the red storm or the red spot that is there on Jupiter. We can look at that. If we are lucky, we can also see the Saturn's rings. Once we see the Saturn's rings, we can also see Jupiter's moons through this telescope. And above and beyond everything, we can look at something 2.5 million light years ahead. Where? If we are lucky, we can look at Andromeda galaxy. This is the farthest way we can see. Andromeda galaxy is the nearest galaxy to our Milky Way, and that is 2.5 million light years away. Andromeda galaxy. I want to tell you something that I have discussed in my book as well. Time travel. And that is, if, for example, just think that there is a planet in Andromeda galaxy. Just take it as an example. There is a planet in Andromeda galaxy, and that alien on that planet in Andromeda galaxy is looking at through his telescope on Earth. As we are looking at Andromeda 2.5 million years in the past, it's in the past. So anyone who is there in Andromeda galaxy planet, if hypothetically that person has a telescope and he is looking at Earth, what he will be seeing in his telescope? Not us. primitive human beings 2.5 million years back in the past. Therefore, if, hypothetically speaking, if there is a speed greater than the speed of light, if there is a speed faster than the speed of light, let's say multiply by 2.5 million, speed of light multiplied by 2.5 million, it means instantaneous travel. Hypothetically, if instantaneously that alien comes to Earth right now, he won't be coming to Earth and meeting us, he would be coming to Earth and meeting the apes and saber-toothed tigers and woolly mammoths and all the movie of the Ice Age would be going on real time in Earth. I call this concept of time travel as instantaneous time travel. A part of it is hypothetical and a part of it is practical. Practical, when I present to you this can be done, of course I have proven it. But it is hypothetical because so far we have not been able to judge any speed greater than the speed of light. But there is a twist to this story. Another theory is emerging that the universe is expanding faster than the speed of light. The expansion of the universe is faster than the speed of light. Therefore, the speed of light is not the ultimate speed. If the universe is 13.8 billion years old, the circumference of that circle of the expansion of the universe should be 13.8 light years. But if it is 90, it means that it is expanding far greater than the speed of light. Therefore, that x hypothetical speed of light has already been broken. Coming back, if we are going to decide a day, or rather, we are going to decide an evening when we will be inviting all of the college students. I told the principal that college students should be invited and they would be looking at the night sky with this telescope. I aim to see Andromeda in it, Andromeda galaxy. I aim to see the North Star, the polar star. I aim to see the Jupiter's red spot. I aim to see the Saturn's rings. I aim to see Jupiter's planets. And I aim to see, of course, Venus, but Venus has got nothing special to offer. So constellations are there. Those students who are very enthusiastic about astronomy, about the night sky, I will be making a group of those students. And inshallah, in the time to come, whenever we have any opportunity of going outside the college, looking at the stars and the galaxies, you will be given preference.